Within the ImAFUSA project, we're conducting these experiments with the aim to have real-time information and feedback from citizens on their views, perspectives, and the impacts as they understand them from the deployment of drones within inhabited environments.
So today we are performing an experiment. The experiment has two parts. The first part has to do with social acceptance, and the second part has to do with drone noise perception. Why is this a unique experiment? Because 4 different partners combined their different approaches and created one big experiment with 120 participants in 3 days. This creates a very big data set that can be exploited by a number of researchers, not only in this particular project but also outside it. And it is a data set that has not been created there before. So, how the experiment runs? In the beginning, the participants are asked about their beliefs or perception of social acceptance. So, do I like drones flying in my city? Do I not like? Do I know about it? Do I not know about it? The second part would be normally a video, and then we would ask them again, how do you think about these topics now? What do you think? What was different here and unique is that we basically embedded between the before and after questions a social experiment on the noise perception. So that is the big difference between a normal survey for social acceptance and this survey. It is experience-based, and we don't have a video, we have real drones flying, people experiencing them, and then answering the second part of the survey.
So in order to collect this information, we have designed a process that allows the participants first to be informed about what the contribution of our project is. Then we collect some preliminary information about their views on these new technologies of innovative aerial services and urban air mobility before seeing the utilization of these technologies. Then they have the chance to be exposed at the outside environment and actually see how the technologies are used and how someone feels when these technologies are used within inhabited environments, in this case an urban environment in the city of Egaleo in the Attica region in Greece. After having been exposed to these movements and activities conducted with these small drones, again we see if their perception of the appropriateness of their utilization in these kind of environments is acceptable or not.
Besides our role as event facilitators here today, Future Needs is also wearing the research hat in the project. For me as a researcher in the project, the data collected here today are invaluable because it's going to help us progress the work we are doing. Future Needs is leading the socioeconomic index development and we are working on figuring out the best possible indicators of assessing the costs and benefits of UEM, and the specific indicators we're working on in the project we are trying to define are regarding welfare, vertiport accessibility and pricing.
So the impacts of our work are really important because it's something based on citizens' perceptions, and we want to explore what people want in the future so that we deliver the best service that we can to make this urban air mobility a product that it is approved by citizens and that is something that is aligned with the expectations of the citizens.
A sound walk, we ask people to take in the soundscape as a whole. So how the whole area, all the sounds in the area make them feel. So we ask the proportions of sounds that they can hear in terms of produced by humans, produced by machines, produced by nature, and then a series of questions to assess their emotional response and correlate those. And what we're trying to assess is how the introduction of the drone sound affects people's perception of the soundscape as a whole. So we're not necessarily asking people to concentrate just on the drone, we're asking people to listen to everything, but then how does adding the drone over the top actually change their perception of the entire area? And that's what the experiments are about that we're doing here today, from my point of view anyway.
Yeah, and from the TU Delft side, we're mostly focusing on the noise metrics itself, less on the psychoacoustic. We have the array of 112 microphones, and that's to capture, so we can make a picture of where the sound is afterwards, so we can find the actual noise sources on the drone, and we can get a picture of what it actually looks like.
So what we are trying to do in ImAFUSA is we are trying to develop the tools for regulators to understand, assess, and mitigate any impacts that the operations of drones and eVTOLs might have on communities. So we are really interested in getting in touch with drone manufacturers, drone or eVTOL manufacturers, or operators, and also regulators. So the tools we are developing, we are hoping to be of use for the industry and regulators. So if anyone is interested in what we can do in terms of the noise modeling and assessment, it'd be great to talk to them. Yeah.
Our work is really focused on assessing the impacts of urban air mobility in community life. So if we don't have a way of measuring these things, we will never know what the impact is before we implement things. So the idea is that if we do this work before, and if we put in the efforts to really understand and study what the impacts are in social life, then we can make life better and minimize the impacts, the negative impacts